So welcome once again. This is the lecture number 4 of the artificial intelligence class. And in this session, we would continue our discussion on the type of agents. So, and also we would see there's some problem formulation in the AI domain. So if you have any problem, how can you model this into correct way so that you can start going and solving this. So in the last class, if you remember, we were actually talking about something very interesting that what are the different kind of agents possible. So we have seen that there are actually 4 kind of agent possible. Kind of agent means they are definitely going to have a characteristic difference between each other. So one is the reflex agent, okay. Another is a model based, and then we have seen third one was a goal based, and the last one was the utility based. So briefly, we have discussed that what is the difference between them in the last class, but I think in the interest of completeness, I should just bring these things. So forward these things: reflex, 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 model based, and goal based, and then utility. So why I wanted to talk about them here itself, because you focus on the differences that they have. So the first thing is the reflex one. Reflex has if then condition. You can think in the terms that if something happens, then what to do. Okay, if there are conditional rules which actually tells that if something happens, I have to do this. So you know that finding out the matching is actually not a big thing. If the fixed number of ifs conditions are there, then finding out that which is matching is nearly order of one time. Don't think that it is going to be matched in by using the loop. It would be you can think in terms of the multiplexers, that if I want to find out within, there is no time in accessing the first or the last one, so we can develop a right kind of circuit for that. So immediately when something happens, it knows that what I have to do and it applies that. So reflex agents are actually, that's why, very fast, because if then conditions are there and they are very fast, so they are very fast. And for example, when as I told you in the last class, that if there's some flies comes in front of you, you would not take any seconds, any time to understand that what kind of fly it is. No understanding is required at that time. You just immediately have to blink your eyes. In the same way, if you are going if you are driving on the road and a car in front of you actually is a red light actually glows more, means what he has applied the brake. So immediately you have to apply the brake if you are distance is very less. So you need not to think about that. So those things which are actually collision avoidance or anything critical kind of thing, in those situations, reflex agents are very important. But the problem is that since they are not aware about that what is the situation, etc. So big tasks cannot be done by them. So one improvement could be that it may be possible that you say that different kind of states are possible, and conditional rules are different for different kind of states. Okay, if different kind of states are there, different kind of conditional rules are there. And then you first try to see that for in which state I am, and then based on that state, if you try applying the conditional rule, it could be a better model. Are you able to see that? Earlier the model was one, but now there are multiple models. So I'm going to pick the particular model. For example, if somebody is craving and he wanted to eat something, so there are different models. That if it is a morning, it is a breakfast. If it is a noon time, then it is a lunch. Evening time, then snacks. And so you can know that what are the things over snacks. So the same phenomena, that I wanted to eat something, have a different kind of flavor over there. So you may think in multiple ways that there are, based on the states, now you are into this particular states. That's why you would be applying the things related to here. So model maintains what? States. Model maintains what? The states. So based on the states, it acts. Again, it is going to be very fast, but it is aware of the different kind of states. Next thing is a goal based. That is a very interesting thing. So goal based, what happens that why you are performing any kind of task, you are going to perform anything because you at the end you want to solve some problem. So you can think that it also introduces something, that what is the relationship, that if I apply something, so based on my actions, it may be possible that I go into this state, from this state to this state, this state to this state. So now we have a relationship also, that how can I change the states, in which state I have to do what, something like that. So so you can more generally think that it is going to be, let's assume that you have a graph and where the things are actually going to be connected in some way, and now your task is that from one state you want to go to the another state, do something. For example, if you are if you are here, you wanted to reach this particular place. So differently from here, you can take this path. Then after that, you can take this path. Then you can take this path and this path, any kind of path. So goal has this sense also, that what is my goal? Goal-based agent has this sense, and by this, whenever he takes an action, he have to do something so that it reaches to this particular thing. So what he have to do? Technically, if we don't be very specific, you can say that there is some planning is needed. Okay, am I right? Apart from just taking the decisions, because multiple decisions are possible. If you are at this particular place, you can go this side and this side also. So which decision you should take? For example, if you are here, you can go here also and here also and here also. Which direction you should go? So you have to do a planning, and then only you can perform this thing, goal-based things. And if you have a plan, then based on the plans, based on the scenarios, you have to search. Because in the plan, you have to explore that what exploration, and then searching that which one are going to be better, and then planning and searching, both the things comes. And based on the planning and searching, then you find out that I should go into this particular direction, and you reach from here to here. So I wanted to register a line in your brain. And this line is that if you want to solve a particular problem, which kind of agent you should go for? Reflex, model, or goal? Can you tell me? The answer is goal. Okay. Any doubt on this? We should go for the goal-based one. Okay. By saying this, I'm not meaning that reflex agent are not going to solve the problem. They are also going to solve the problem. Model based are also going to solve the problem, but goal is more likely to solve the problem because it is doing some planning also. Okay. So any views on this? Okay. So we will come back to with more details over here, and then what comes the utility one. So till now, when this is only goal-based thing, so it is just like that. There is an agent that wanted to be good. There is an agent that wanted to be good. So again, what is the problem with this agent? That if he is very good, I'm not considering that what is this. Its goodness is going to have impact on the society. If it is good, but it can impact wrongly on the society. Am I right or not? Yes. We have discussed about that. That if somebody is only wishes to earn money, he have many ways to do that, and mostly if he goes for the wrong means, he can be earning more. Okay, but
environment you spoke about environment.
What is the what is the effect on the environment? This goodness, what is the environment of what is the effect of this goodness on the environment? So if we want to control that particular part, then it becomes the utility. When I'm going to concerned about the environment also, then it becomes the utility one. So these are the four things. We are going to come one by one on this once again. So simple reflex agent, as we discussed, more technical details are here. So simple reflex agent, again, there is an environment, and from the environment, this is the agent. This complete thing is inside the agent. So there are some percept, it replies outside to find out what is the environment. So from this, it gets the percepts. Okay, it applies the sensors. Sensor is a part of agent and applies something. So the sensors, so that find out what is the percept. Percept is coming from here. Percept means what is the state? Something. He's perceiving something. And using the actuators, he actually starts some actions, and that action happens into the environment. This is the standard thing that we are going to see multiple number of times. So what it says, what the word is like now. Try to understand that what is the word is like now. If there is a fly coming with a fast speed in front of my eyes, or is there a red light blinking in front of this? then I have a conditional action rule, condition action rules that tells that in this condition you have to do this. So by this you find out that what action I should do. And for that action, you actually actuate the right kind of actuators, and then the action happens. Very simple. So essentially, it is the same thing that you get a percept, and then you interpret that input and try to understand that what is happening right now. So what is happening, and using the predefined input stored rules that you have, you find out that which rule I should apply right now. And to apply that particular rule, relevant actions are actually sought, and that this action is written that do this particular kind of actions. Actions means activating the actuators. So by this, it performs the thing. Sometime a question comes here that, sir, you told me that it is not goal-based, means it is not going to solve the problem. So whether it is can it solve some kind of problem or not? Okay, if you have a big problem, any kind of problem that you have, can it solve a problem or not? So any idea that you have? First, like to understand that can it solve a particular problem? So when I say the problem, right, it is just not action based, because right now what it looks that anything is happening in front of you, it is going to take the action. There is no long-term thing that I'm solving this particular problem. Right now, it is saving something, doing some kind of action. Only this part, till this part, it is actually restricting itself. So, what do you think? That can it solve a problem? Any idea?
I think we need more conditions and more combinations of. I mean, we need to get more percepts and more combinations of the conditions
So
to cover
so
the.
right now,
I mean, yeah, to cover the problem.
Yeah. So multiple percepts are actually, that's why written percepts. So whatever kind of percepts you think, percepts are coming sufficient. Look, percepts are going to be there to understand the environment. So let's assume that sufficient right now, sufficient percepts are there. So my question is that if you get the right kind of percept, will it be solving a problem or not? Let me give you a problem. Let me give you a problem. So that it becomes more clear to you. Let's assume that there is a city. Every city has a map. Every city has a map. So there is a map. So some map is there. So let's assume that he is somewhere. For example, let me say that he is at this particular place. He is at this particular place. And his house is here. He want to come here. So can he solve this particular problem? That this is the problem, na? If he is here, he have to reach to this particular place. How to reach this particular place? How whether this particular agent, which is, if it is a simply reflex agent, will it be able to reach this particular place?
No, it should, as you mentioned, it should be goal based to see what is expected out of it, whether we should reach fast or we should reach in a shortest path, or based on some goal, we will probably we have to
correct. But now why I'm telling that this is my goal, but agent is not taking that thing in. There is no factor inside the coding. Inside the agent, there is no understanding of the goal. So I have a goal, but can it solve this thing? That can it reach over here? Yes or no?
Yes.
You told
yes.
Yes. How? So then it is also goal based.
No. Reflex agent cannot, but if it's a goal based, then we can.
Okay. So right now we are only considering the reflex one. Okay.
Yeah, reflex. Right, I think it cannot, because it's
reflex
based on the condition. If it is this one, then do this action.
Yeah. So your understanding is perfect, that it generally does not solve this particular problem, but there are some other things also. For example, while teaching you, something comes in my mind that you know that there is a car, toy car comes for for small kids. Have you seen that there is a car which actually goes by in automatic way? So it goes in front, and if there is somebody stands over there, it actually it takes a U-turn and or goes in this particular direction. Have you seen that car? It's a toy car. there is some sensor. It does not go and collide with someone. It goes somewhere and it come back and again goes to the different thing. Okay, somebody is standing over there, so people play in this way. So it again goes back and goes there. Okay, so it's a kind of random thing that he is going to do. Randomly ultrasonic sensor, professor. Yeah, there is some sensor, and then using the sensor, I think proximity sensor will be there. So if anything is nearby me, that in front of me, then he take back and come back again. So there is something called random walk. So it's a subtle mathematical method. It actually says that, let's say, and the problem in the random walk is also same. So there is a city. In his city, somebody is sitting in a bar and he had drunk enough that he don't know that where is his house. His house is also inside the same city. So what he started doing, that he came out of the bar and he took the random path. And here he randomly pick anything. He randomly pick anything. He randomly pick anything. Randomly pick anything. He goes again. Any path on every class he is going to take the random way. So there is a central method that it will take some time to reach over here. Okay, and definitely he would reach. Okay? In infinite amount time, he would be exploring all the path, and that's why he would be reaching here also. So this is I'm giving you the hint that how can you solve this particular thing, that in how many times what is expected that it will take all the paths covered. So let's assume that when he reaches in front of his house, then he recognizes, okay, this is my house. He goes inside. So so in this way, in the random way, these agents can solve the problem, but they don't have the planning. So efficient way of solving is actually not there. And actually, we want the efficient way of solving. That is the important thing. Okay. Now I'm going to make this reflex agent better. And this reflex agent is actually going to be model-based reflex agent. Again, it is a reflex agent. And model-based means, as I told you, that there are various states. So it is going to maintain something that is called the state. That what is the state? So in the agent, there is one more thing, that what is the state and how word evolves. This is also important. How word evolves means that from one state to what happens that you states the word, change the word. So maybe there could be a clock which can tell that this is a morning time, evening time, something like that. So there should be something that tells that from one state how I change from one state to another, because otherwise he would keep working on one state only. Okay. What my actions do, he knows that if I apply this thing, what is going to happen over there. So again, the same kind of setting is there, that from the environment, it takes that percepts are coming, and percepts are going to be seen that what the word is like now, how the word is right now. And using my current state, how it evolves, and what my actions do, what I'm going to do, that I'm again going to access my condition action rules. And these conditional action rules are going to tell me that what action I should take, and then I take this particular action. Make sense?
Yes, sir.
So important thing, there is again a very important thing, that what is the state is very important. Okay. So you could be into this state and you are taking the decision based on this. If you could be here, you can take the decision on this. You can build up your system can build your understanding also. So for example, this I should not use this word, but don't quote this. Let's assume that there are country A, country B, country C, country D. Okay. So you know that when I tell country means every rule changes. By country means what? That the rule changes. So if you are into the country A, different kind of rules are there, different kind of rules are there, different kind of rules are there, different kind of rules are there. So you take the decision here different, and here you also take the different decision different based on your requirement. Okay, I'm not into that much detail, but this thing. What I wanted to tell you, that that the word is same, na? Everywhere the word is same. Is it right or not? Everywhere the word is same, but the rules are different. Why rules are different? Because the understanding of the people is different. Am I able to make this make sense? If you go into from A country to B country, why rules are changed? Because they are thinking the peoples are into the different way. Looks like that our peoples are like this. Doesn't make any sense. On the earth, everybody is same. Okay, they are thinking the peoples are like that. Okay, They are thinking, they don't make the rule that what is happening into the country A, and that's why I'm making this particular ruling. They think that our understanding other people's is this. Am I making any sense?
Yeah, yes.
Okay, so this is very important, that what the word is not important. What is our own understanding is actually important, and we make the rule based on our understanding. This is a very important thing. Are you able to see that? Okay, so this is very interesting thing that that in totality, what I wanted to tell, that word could be different. Okay, word I should not say different. Word is word. Okay, but its understanding could be different. So I can generate different understanding out of this. Okay, let me try to give another example. So somebody thinks, if somebody is very spiritual, he may be thinking the word is spiritual. Okay, and that's why he is giving the, if somebody comes to does bad with him, even then he does good with him. So what is his understanding? The word is spiritual good. If there is a bad person, what he thinks? So somebody sometime told me that I like this statement, that a person who actually bad person, his problem is that he thinks that everybody is bad person. There in the world there is no good person. Okay, so if somebody is bad person, he thinks that everybody is bad. If somebody is good, he thinks everybody is good. There could be other kind of peoples also. So I just try to give the extreme example, that this agent is thinking the everybody is bad in the good. This agent is thinking everybody is bad. This person is thinking something else of different kind. So word, this is state, and how word evolve. This is the understanding of my agent, and that can be different than the word. How the word is, nobody knows, because if he knows, then why he is thinking the word is good, why he's thinking the word is bad, it is your own problem. Okay, so how the word is a different thing as compared to what is the model that for how the word is. Am I
So you
making
mean
sense?
the interpretation here, right?
Yes, this interpretation is different. So this model is not exact word. Na? How, because word may be into the very, actually this is not possible, because word operate in a very high dimensional space, maybe 1,000 dimensional space, 1,000 things are there. Then only you can tell about the persons. But how can you measure those 1,000 things? You can measure only 10 and 20 things. So uh, you have to cut down your thing so that this 20 characteristics you want to understand, what is loyalty, what is punctuality, something, some kind of the 20 characters only. And then by this you can tell that I'm going to make the model of my word. Understand? So your model could be not totally different, could be a different representation of the word. So word may not be this thing, whatever your model is. This you must understand, that when I say that there is a state, this state is actually not the word state, but in your understanding, word is into this state. But actually the word may be under different state. That I wanted to point out over here. That word may have been working into very high dimensional space because of your capability, anybody's capability. Nobody can know everything into the word. So he only knows the few things, and that's why he is behaving into this particular way. Okay. Am I making any sense?
Yes, sir. Yeah.
Yeah. So next agent is a goal-based, the goal-based agent. This is our lovely friend, that he is going to solve our problem. Okay, he have a goal, and that's why, and we also want to work because we have a goal. So he is a goal-based agent. So again, the same kind of setting. We have an environment, perceptor is coming. I'm going to use actuator to do the actions. Here I have a state. How word evolve, the understanding of that thing. What my action do, same thing, nothing more than this. So one more component is only added, that what it would be like if I do the action A. So whatever action is actually suggested by you, what my action do. So you find out that based on this, it suggests you an action. So now you also consider what it will be if I take this particular action, because by this you are changing your state. So based on the goal, now you decide that whether you are going to take this action, or out of available action, which action you are going to take. Because now you have to go near to the goal also. Okay, I think this is very pretty simple, and I think you all know about that because we have to go into that particular direction. And for that, as I told you, that you have to do the planning, you have to planning, and you have to do the search. So you can see that there is a solution, and to reach the solution, what is the shortest path? For example, right, you want to reach the thing, but you want to go into the shortest path, na? Into the state. So there could be algorithm that are going to tell you that go into this particular way and solve this particular problem. So search and planning are two important things which actually are introduced because of this requirement that I have to reach to this particular place. So this is the goal list. Next is the utility-based agent. That is a ultimate goal that we wanted to make. And here I'm going to provide a utility to the system. That what is the utility? When you are going to do utility into the environment, utility again is towards the environment. That what how happy I would be in such a state. So I means environment. How happy I will be in such a state. Environment, because ultimately, apart from all these things, one more thing is actually said over there. So this actually makes controls his actions, so that out of available actions it actually tells that no, few of the actions I'm going to kill, these actions are not good, so for the remaining one only you take them. So whatever action is suggested over there, for example, somebody tells, in our case, that in our extreme example where I was telling that somebody is going to do the bad things, again, the system is going to do, I would not be happy if this action is taken. So those actions actually eliminated. For then out of available things, I want to take the maximum one out of this. Okay. Once again, you can think in this way. If somebody want to be rich, there are various options that you read. You open a shop, you start provide a service to somebody, you go and steal, rob the bank. All these things are there. So then the system is going to say, I will not be happy if I rob the bank. This action has been dropped. Then from the available ones, you are going to take the which action I have to take. And then definitely the system is going to be into the better state. Yes or no? Again, the important thing here comes that you already know that how happy I would be is again a very difficult question to know, because you don't know that do everything is not fixed. Next time the environment would be coming to you in a different way. So you don't know that what is actually in the final utility, how I can make it the best. But right now, based on the current situation, what is expected to be maximize my happiness? So right now, happiness again is a rough word. Okay, you can think that how better we can be. So this is how we actually proceed. Expected utility, and what is expected utility you want to maximize. Things are not going to be perfect, but every step I'm going to take the right decision that takes the expected utility to be maximization. All right, any questions?
Sir, here, as per the slide, it says how happy I will be in such a state. It gives a meaning that it is part of the agent here, as per the
No, no,
slide.
no. I means environment. I told
Oh,
you. Yeah.
environment. Okay, okay, sure.
I hear because everything is made for the environment. So I'm talking in terms of the environment. So here I is environment.
Okay, sir.
So I think your suggestion is good. Let me write over here so that I can change environment. Environment will be in such a state. I would try to change this into the next slides. Yeah.
Sure, sir.
And you may think in this way, na, agent would also be more happy. Okay. Agent is good, but he's not happy. Just try to see that happiness is different than the being rich. For
Okay,
very
okay.
for very
Yeah,
long, people are telling like this that being rich doesn't mean that you are happy. How happy I will be. So you can think
yeah.
in that way.
Okay.
Any more questions, please? Anybody? Any questions?
So what does maximize expected utility mean, sir, in this?
Yeah, yeah. So actually, what happens now? What does maximize utility means? So utility is something that you want to be, there is some goodness factor. Utility, from the utility, you can think that happiness. Let's assume that the country GDP, high GDP. I'm not sure of this. Again, I have to measure in some way, so that let me say that it is country's GDP. I wanted to make. So utility is country's GDP. Okay, you want to make it more. So how can you make that thing more? You take those actions so that by this more money is generated to everybody. You are going to take those kind of actions that can make. Maximize utility means what? You are going to take decisions so that it actually maximizes. Yes or no? You find
Yeah,
out
got
the
it.
you maximize that the value is going to be 100. Maximum value is
Value.
going to be 100. But would you be able to achieve this 100 rupees? Answer is no. Maybe you can achieve 110 or you be able to achieve 90 because random things are happening. Na? For example, there is a samosa wala. We want to sell samosa of 100 rupees till the evening. But it may be possible that many people come and he is able to tell more samosas. He's selling samosa of 110 rupees. Somebody is, but maybe possible less people are coming. He's only able to send 80 rupees. So this is expected. 100 was expected. This 110 and 80 is the maximum value. What is the maximum value? Maximum value is 110. But expected value, what he was expecting, 100. So we actually go for expected only because he cannot in the morning tell that I would be selling the 110 rupees samosa. Okay, because you don't know that what is going to happen in scenarios. Am I making any sense?
Yes, got it, sir. Thank you.
Okay,
I
so
think it
that's why
is on the utilization and how effective it is, how effective the agent is, how rational as well as effective, how to achieve benefits using the agent.
so this part please also include that he don't know that whether it would happen or not. This, if you bring this
Yeah,
particular factor, I am thinking that this much good is going to happen, but because of randomness into the system, I don't know that whether those things would happen. So I am hopeful that it is going to happen, but actual values would be different. And this is happening because of the freshness, because of the different kind of noise, different kind of uh, factors that actually come into the system as a randomness.
got it.
So
Yeah.
that's I put this expected value. And
Sure,
I
sir.
want to maximize the utility. Everybody knows about that.
Okay, got it. Yeah.
Akshay, do you have any question? Ritesh, just picking the random names. Don't get offended. Jitin.
So, Polomi, one quick question. So here, how happy I will be in such a state? So here, I refers to environment, but in the next, what action I should do now? This I refers to the agent, right?
So I told you that a few minutes back, I had a discussion with Vijay when I was telling that how happy I would be and how effective I would be. Okay, these are the two different things. So maybe if I put the money earning agent, he would be very rich, but he's not happy because
Right.
you have this. So happiness and this effectiveness, I can say that it is different thing. What action I should take? I means agent. Okay, so agent would be
Agent,
taking. So
right? Yeah.
I can take in that way. So
Hmm.
here also you can think that this I is about the agent only because agent is for the environment only. So you can think that agent is here. So let me correct it that this is also agent. Okay, because
Right.
he
Right.
is rich,
Sure.
but he is not. He is rich, but he is not happy. To be happy, he have to make something in the environment so that everybody is appreciating him. So he becomes happy. Happiness is a different thing. Yeah, makes sense.
Okay.
Yeah. Thank you. All right, so we have seen the four kind of agents. Now let us try to understand that if we want to keep improving it, okay, general learning agent, because we just don't want to make the agent, we want it to be a general learning agent. So it keep learning, it keep improving as it goes. So if I make a general learning agent, what should be the criteria? What should be the method to do that? So this is a kind of block diagram, and please focus. This is a very interesting diagram, and need your full attention to understand. It's very simple, but I invite questions from your side whenever you have things to ask, please ask so that it becomes more clear to you. So again the similar thing. I want an agent, so there is an environment. From the environment, percepts are coming through sensors, and through actuator action is going. So four kind of agents we have taken. So this is the agent. Okay, this is the agent logic part. Let's assume that this is the logic part. Performance agent, performance element. What is the performance element? Performance element is the code of the agent. So till now, if I say that what we have seen, so we have till now we have seen only this particular part. Must be clear about that. That whatever we have seen, we have seen this particular part. So few things are more I'm going to introduce. What are those things? Performance standard means what is my how, for example, let's me take that it is a autonomous vehicle. So what is the performance standard? That how legal plus comfortable plus fast. This is my performance standard. I want to implement this thing into the system. What is the performance standard? What I wanted to make good. Then I need another element that is called critic. This element sees that what was the environment, what was the percept. It is also passed to him. He also needs that, sees that there was a car in front of me, and he has blown the red light, but I have not stopped. Okay, so think that action is also always available to all of them. Okay, so he sees that this performance element has taken this decision that I am going to press the brake in with this pressure, but he must have applied more pressure, then only the car should be able to reach stop at this particular moment. So what action this performance element has taken, it is available to him. And what critic thinks that he should take this action. No, he have taken wrong action. Understand? Or okay, it has taken the right decision. So this feedback is provided by the kit. He generated by the critic. So what critic does? Can anybody tell me? Based on the performance standard, based on the environment condition, he sees that whether the action taken by the performance element is correct or not. Who is going to tell this for me? Jatin, can you speak? Mitlesh? I'm just randomly picking the name. Kollu?
But Professor, the actions are not yet taken, right? I mean, it is just the sensor is there.
So please understand that this part we have already discussed. Okay. So in this performance element is the agent. It is actually working. Let's assume that it is working. Okay. So he is taking some action in the environment. Something happening. He is taking the decision. If this part is working, let's assume that this part is working. And whatever he is doing, he is putting into the log. This log is being seen by the critic. That what was the condition and what was the expected action and whether you have taken the right action or not. Yes.
Okay.
Okay. So what critic is doing? He is evaluating and giving the feedback. Okay, you should have done this. Okay, fine, you are doing good. Something like that. He is providing some feedback. So how to provide the feedback?
So sorry for interrupting. So it is like the critic is evaluating the performance element decision, not the action. Because the action will be taken from the actuators. So the decision on how to act is done by the performance element, and that is evaluating by the critic.
Okay, so you wanted to mean that actuators are actually performing the action. Okay, but this action, I can think that this action is initiated by the performance element. So
it's like what is initiated is evaluated.
Correct. Yeah. So we can just roughly say that it is the action that is being taken. So you can think in that way. Okay.
In a past tense,
yeah. So this action, whatever action he has taken, but because my performance standard was this, So he must not have taken this thing. So for example, I just wanted to give example. Maybe if there is some life-threatening happening with somebody and it is an ambulance car, then at that time, if he crosses some red lights, so it is fine. Okay, it may be fine. I'm not sure about that, but it could be fine. So the task of critic is to see that how good this particular performance element is working based on these standards. Based on this standard, what is this? How good it is working, and then he formulate his feedback and provide the feedback to something called the learning element. This part is clear? Can you write yes?
So, Professor,
Yes, sir. So the critic,
Professor,
you are
one-
saying it is after action only, not before the action.
Yeah. After action, yeah. After
Okay.
action.
So does that mean the critic is performing the job of an analytical tool based on the existing information, the actions taken by the agent?
Yes, that was precisely right now my question was that how can be done. So definitely he have to do analysis that in this situation what I have to do, and then he tells that this is the feedback that I have. Yeah. Okay.
Professor,
Alright,
Professor, how can we ensure that whatever feedback critic is giving, that is the best one, and like the agent should learn that for betterment?
may I request one thing that please don't call me professor right now. Okay. Now onwards, everybody don't call me professor. I feel offended. Okay. Just talk to me. We are you both are on same level. Okay. We are discussing. Okay. Thank you. First thing, and it was not for you. Okay. It was not for you. For everybody, please don't call me professor. Okay. Fine. But your question is wonderful. What you asked that how can we know that critic is doing right thing? This is
Yeah.
your question. Okay.
Yes.
So we need something on that also. Maybe again, ever the prime minister, there should be someone. कहते हैं उसको, party, no? They were telling that there should be some super person over there. So again, it doesn't solve big problems. Okay, then you would be telling that above him somebody should be there. So I think hierarchical structure is there. At some place you should stop and you should believe that he is working good. Okay. Maybe maybe there should be some other things which actually at the later find out that he has provided me something earlier. The performance was 90%. Based on his feedback, if something has been done, performance becomes a 70%. So definitely it is working wrong. But right now, I think we should right now maybe those things could be not our understanding. We think that okay, it's a good algorithm now. Whatever available good algorithm we have that algorithm.
Also, is it based on the performance indicators? So for example, it is capturing all the
Definitely.
information as action, and
Definitely.
if it is crossing that threshold, yes, ultimately it is a better action to be performed for the next stages.
Yeah, definitely. Based on that only he is going to tell me the feedback. Okay. Based on because first thing is that is given to critic is the performance standard. Based on what performance you are going to evaluate me. Okay. So performance. Yeah.
But to me, it looks like to me that the critic is acting as a model-based agent, isn't it? I mean, we have some performance standards, and based on the state, I am giving a output as an action. That what is my feedback?
I think you should think in this way that it is a goal-based agent because he have a goal that I have to maximize this particular quantity. So this is one agent. This is another goal-based agent. You want to find out that. Make sense? And here the environment is actually even larger as compared to this because what kind of environment could be there? So it have to work more on that particular thing. Right? Excellent.
Yeah.
Achha. Any more question? So all right. So we have understood this till now. This what we have understood that there is an environment and there is some agent is working in this based on the requirement that what I wanted to maximize in terms of the performance. So I want to, there is a critic that actually evaluate that what action is taken by him and provide the feedback. Then there is a learning element. This is again important thing. Learning element is someone and try to see that they are different. What is important over here, that try to see that they are different. Sometimes we think that everybody can do all the tasks in the organization. We need these components. This is a different component. What it does, let me tell you. Learning element is asking from the performance element. Tell me your knowledge. Tell me knowledge here. The knowledge means what? These if then experiments, all these things that he had. This because ultimately we are going to make whatever kind of if then is statements, they are going to represent that what knowledge he have, and based on that knowledge he is going to take this. So for learning element is seeing, acha, you are taking this decision. Tell me, show me your knowledge, because based on this you have taken this decision. Na? I can tell you that how to update this knowledge, because this knowledge, if you update over here, then you will be taking better decision. Once again, technical term came, that is a knowledge. We have already discussed about that. Knowledge is a very important thing, and knowledge does not come from the data; it comes from some understanding. So this understanding this particular agent has, learning element is telling, show me your knowledge. Why you have done this wrong? Let me check your things. And then based on the feedback, he checks and provides some challenges that these things are there. Looks like that these things have you must change to be better. Am I right? So learning element is telling that these things you should change so that you can be better. Is this part clear?
Yes, sir.
That's very simple. Yeah. Okay. Now comes yeah. Go ahead.
So the problem generator does suggest the
Please. We have not talked about problem generator. We have not talked about problem. Okay. Learning element. We have talked about learning element. He is telling, okay, critic is telling me that based on the feedback, I would see that what knowledge you have. I would open all your things, see they go why this happened wrong, and then I would provide some challenge that you take this thing. Challenge means why it is challenge, that can you correct these things, that looks like that there is a problem. This could be a problem. Would you like to change this particular part? Yes, say again.
Sir, one question.
Yeah.
If performance element has taken the right action, right? So then this learning element won't be giving any challenge. Okay, only the time when performance element has taken a wrong action, at that time the critic will be telling like the feedback. Okay, this is the problem is there, and then.
Yes, Abhishek. So generally, it is not only that he has taken the wrong decision. Everything is not right and wrong. Sometimes happens that if I take this decision, then the performance standard would be high. Okay. So maybe right decision, but based on the performance standard, I'm going to tell that, because the person is not that much happy. If you take this thing, he would be more happy, something like that.
Yeah.
Okay. So feedback I'm going to get, continuous feedback I'm getting. Sometimes it can tell that, okay, correct, you are right. So that is also fine. Somebody is raising hand. Please speak.
Okay.
Yeah.
Performance standard, you mean like if it is a shortest path, just for example, if it is a shortest path and our performance element has taken a long path, so at the time that okay.
Yes.
Okay, understood. Yeah.
How legal it is, how comfortable it is, how fast it is, how short it is. Okay, shortest distance, something like that. All these things. So somebody has raised hand. Please speak.
Sir, this is Bala here. So just a question online. The performance standards may vary from environment to environment, right? For example, let's say if my program runs on an engineered system, it may run fast, but if it is running on a legacy or a normal desktop, it may run slow. So will the critic be intelligent enough to derive or adjust the performance standards based on the environment and give feedback?
Yes, definitely. Otherwise, because the task of critic is, that's why he is a separate person. He have to consider all these things. that what is the environment and how the percepts are coming, what is my speed, what is all these things. Because look, just think in this way that you are from outside thinking that there are two different kind of, one is legacy, one is very good environment. You are thinking from outside, but think from the perspective of inside. Now you don't have any choice. If it is inside the legacy system, he have to improve the legacy system. If he is inside a different system, he have to improve that system. So for the critic, environment is not changing, it is fixed. So whatever environment he have to improve the performance standard over there. Yeah. All right, very good. So excellent. So we have discussed till now that that there is a critic he is providing, that in this way you can improve it. Learning element is opening all these knowledge, that means checking that how you are taking the decision, what is your system, and then he is providing that, okay, can you change this particular part so that you can be better? He is suggesting something. And now comes
One
a very
question.
important. Yeah, go ahead, man.
Sorry. Just to quickly, this learning element, it challenges and the knowledge. So which action happens first? Does it challenge first, or does it receive the
No,
knowledge
so,
database?
okay, so let me do this thing, that let me just remove this thing. Okay, so I think I'm sorry for this thing. So there is a arrow over here. Okay, so arrow is this in this particular side. So it means that if you take input, then only you can get output. No? So this challenge is going inside this side. There is an arrow. So first he would open that, what is the knowledge you have? Give me the knowledge. Tell me all the knowledge that you have. He just checks what are the conditions. For example, he's checking the code. What is your code? He analyzes that code and tells that, can you change this particular part? And challenge means what? He is telling that, what can you change this particular part, and then you will be better.
Sir,
Does it answer?
here, yeah, as you said, once it's challenging it based on the feedback from the critic, it's suggesting something back, challenging something back to the performance element.
Correct.
Right,
Yeah.
and the performance element applies that action through the actuators.
So
And
till we
the
have not
next
talked
feed,
about that. Till now we
okay,
have not
okay,
talked about that. Yeah.
okay,
He is giving the challenge. Okay.
okay.
Can
I thought
you
that the
change this?
knowledge comes
Yeah.
back once the feedback is corrected, or the feedback is looking good after it is challenged.
No.
What I
So
thought, okay.
right now I wanted to check that I got a feedback, whether how can I incorporate this feedback.
Okay.
So he is checking the code. Okay, and he provides the challenges. Now it is a part of performance element that whether he should accept this or not. Okay, again he have to accept it. So to see that everything is happening or not. Okay. So what happens now, that everybody is sitting. I'm sorry that sometimes I'm using the political things over here, but don't consider them. Okay. So what I'm telling, that everybody can tell that he is a my mayor should do this particular task. I have to. You can tell that your institutions that he should implement this particular policy to make the things. Everybody can tell. Everybody tells to the system that he should do it, but the system has some limitations. Okay, and based on that limitation, he have to work. Am I right or not? So here comes this particular part, that is called the problem generator. He decides learning goals. He decides based on the learning goals, that learning goals that is provided by the learning element, because challenge is provided to him. So why he have provided these challenges? There must be something that I want to improve this particular part. I want to do this particular thing. So uh, based on the feedback and knowledge that he wanted to incorporate, he sets that if I improve this particular part, I would be more better. So this is what the learning goal is. So if I improve this particular part, then what are the scenarios in which you would be behaving in correct way? There could be some scenarios, na? Because this is my learning goal. If I correct this, then I would be able to solve this particular problem. But last time I was, this particular system has taken the larger route. So now if this is the scenario, let me check that with this new change that I have done, is it going to take the shortest route or not? So a few minutes back, you have given me an example that, let's assume that here the learning goal is shortest path, but the system let's assume also that this particular performance agent has taken the longest path. Okay, so right now, if I change this thing, my learning goal is to reduce the path. So if I do this thing, whether my system is going to take the shortest path or not. So let me give you an example. So if you go from here to here, tell me that what is the path you are going to take. So performance element is, he is evaluating the performance element is going to take this path. Again, it is a longer path. Okay, so it is a bad thing. So this whatever changes he has provided, he can drop those changes because you are telling me to change this thing, but by this I'm not going to achieve this thing. Because he is a tester, problem generator creates those problems, sets that check this change on this particular data, check this change in on this particular data. Why it is required? Because otherwise, how come he know that how my efficient, whether if I would accept these challenges, I would be good or not? And in the environment, all the scenarios will not be there. Na? If he wanted to test, for example, there is a Ola car, he wanted to tell that going from here to here. If somebody had not booked the car from here to here, how he knows that? When in the cases when I go from here to here, I should take this particular path. So those fake scenarios are test scenarios are generated by the problem generator. Look, I'm going to book the car from here. Tell me that what is your path. He find out that path. But this was the learning goal. Based on the learning goal, he has generated different kind of problem. And these problem he sends to him and tell him to evaluate. And if he find out that, okay, looks like that on these problem generated problem, I am actually performing better, then he accept the challenges and appends to its knowledge. Am I making sense? Otherwise, what would happen? He is telling some change and he is accepting that change, but because of that change, something else, corner cases get disturbed or a bad thing happens. So there should be a separate system which actually tests that in all scenarios whether I am going to achieve this particular learning goal or not. And then the system accepts this particular part. Questions?
Yes. So the knowledge comes when the challenge, when the learning element is challenging the performance element, and based on that, some actions are being taken. And once the second feedback is good, then the knowledge is being applied back. Is it correct or?
Let me tell you that what the knowledge is. I think we have earlier also told you that if this is a condition, then you take this action. All these set is condition actions or whatever we have, this is called the knowledge. Okay, so you may treat it as a code that is inside. For the very high level understanding, you can think that there is some code based on that it is learning. Learning element has actually seen that code, audited that code, and told that change these things. But before changing, he wanted to test that on that after when I do these changes, whether I would be able to perform good or not. But by itself, it is not going to generate the problem. Somebody is going to tell that, look, from this scenario, what is your answer? This should be the answer. You have given this answer. Very good, excellent. So by using those things, I can again come up with a good method. And then if the performance element means my agent sees that I'm performing better, then he accepts these challenges. Challenges means these changes. Otherwise, he dropped those challenges. Yes?
Okay.
Vijay?
Yeah, so I think the problem generator, the learning goal, and the problem generator does the job after the knowledge only. That's what you mean. After the challenge happens, and the knowledge is also back to the learning element. Then it comes to the problem.
Knowledge is inside the performance element. Knowledge is always there. Code is
Always
always there with
Okay,
the performance element. Okay. So
okay.
it is just like I want to check your code, current code. Give me your current code. I would evaluate something like that. So knowledge is with the performance element. And learning element is telling that change this particular part. This is the patch you apply, something like that. Okay?
Got it, sir. But what? Got it, sir. But in this diagram, what I thought is the knowledge is applied back whenever the learning is actually good. They're learning whatever the performance element has learned, that is good. So now let me apply that knowledge to the system. But the next time when it performs, this knowledge has already been gained. Some kind of best practice. Something like that, I thought so. Now I'm clear. You're saying that
Yeah.
it's just existing code which is there as a knowledge.
Correct. Correct.
Okay.
Correct.
Okay. Got it.
Knowledge is the code. Yeah. All right. So any questions? Any more questions? Anybody else?
Yeah, one question. Actually, I'm a little bit confused over there. So you just said that problem generator is generating a problem, and the performance element that is actually our agent, the code which is written over there, it actually tries to use this problem and resolve it, and then check whether I'm getting the required desired results or not. Right. Based on that, I make the updates. Correct. But if I mean that means then this performance element is doing the job of the critic also at this moment, isn't it? It is
No.
taking
At
those
that time, he only verifies this because problem generator has generated that this is the problem, this is the solution. He sees that whether my after implementing this knowledge, I am going to get the same result or not. So he is not analyzing anything. He just sees that based on my code, whether I'm going to get that result or not. Yes, no kind of thing. He is not doing any analysis. Okay. Problem generator means problem and solution generator. That this is the problem you want. Yeah, I am going to book the car from place A to B. This should be my path. This is the smallest path. Can you tell me that what is your path? Your system is telling. He's telling. I am telling this one. No, this is wrong. Okay. Or okay, you are also generating this thing. This means that this patch is correct. Then you can apply this patch. Yes.
yeah. Okay.
So should we proceed? Okay, thank you very much. So this is a very interesting thing that we wanted to learn. So a few minutes back, I was telling you that whenever actually in the general setting, whenever I say that I want a problem solving agent. I have a problem. I want to solve that particular problem. So goal-based agent is going to be deployed over there that can solve my problem. So generally, the problem, as I told you, that whenever there is a goal-based agent, there are two things are there. One is the planning and search. Planning and search. So search on what? You have to create that thing on which you have to search. So again, this is again an important thing that on which it is going to search. We are going to see some problem formulation next. So there is a technical word called uninformed search. Here what happens now? Let's assume that search, you created this particular thing in graph, for example, from one state I want to go to that particular thing. So uninformed search says that you don't have any information apart from this, from where to where you have to go. Okay, map is there, but on the map you have to find out. Sometimes it may be possible that some satellite information is also available. For example, if you are here and for example, let me just take it big. So it could be possible that from here, if you want to reach to this particular place, so you see that three places you can go here, here, and here. Okay, which place you should go? I don't know. I don't know. So maybe one by one you test that I'm going this direction, then this direction, and this direction. So this is uninformed search. Sometime it may be possible that there is a satellite information is also available. For example, what is the air distance of this place from the B? If this information is also available, this is an informed search. So you can take the better decision. Are you able to see that? Uninformed search, no information is there. So you have to do something to reach to this particular place. Informed search, some extra information is available. For example, I given the example that that air distance of that city to the destination. It would be better. It would be easy to search. But now again, it is not in your hand. If the problem is this, then you have to solve this problem only. Okay. So let me give you an example. And this example is this. Consider an agent enjoying holiday in Arad, that is a place in Romania. Then what is the performance measure? He is enjoying holiday. So what is the performance measure? That how much he have improved his suntan, how much he have improved the Romanian language, how much he have covered the site, how many sightseeing he has done. So this could be a performance measure. Am I right or not? Let me give you one more information. That assume that if he has a flight from Bucharest next day, let's assume that he have a flight from Bucharest next day. So what could be the performance measure? How now what I wanted to have the performance measure, that he should reach to the Bucharest on time. If this is the goal, if I change the goal, so he have to do different things. Enjoying, then these were things were there. But if he have a flight in the Bucharest next day, then the goal is to getting Bucharest on time. Make sense? Okay. So goal is some word state. When I wanted to reach to the goal, so we say that how the word is. So we have to tell that there is some state. In that state he want to be. Agent task is to find out means what action I should do. Okay. And this action should be what action I should take now and what action should I take in future so that I can reach to the goal state. Let's assume then from Arad there are 3 roads. One towards Cebu, another towards Timisoara, and another towards Jarind. There are 3 roads, and you can see that none of them achieves the goal. So it becomes very difficult to choose that where I have to go. So he have to develop some strategy by which he is going to proceed. So what could be a strategy? That I am going to move to the direction which is the lesser. For example, it is 10 kilometer, it is 30 kilometer, it is 25 kilometer. If the strategy is this, that I would take the shortest path, then A is going to move to the Cebu. Okay. So to take the right decision in the comprehensive way, he needs some familiarity with the geography. Means map. He needs some map. Okay, he needs some map. Then only he can go ahead with that. Try to understand that here the environment is observable. Why? Because he knows that what are the places, because he have a map. If he have a map, then he can decide that what are the things over there. He knows, he can see that where I am, what is in front of me, what is behind me, everything he knows. Okay. It is a discrete environment. So I'm defining this as a discrete environment. Means what? As I told you that on the map, there is one city, another city, another city, another city. He can be here also, but let's now only consider that he has either into this city or this city or this city or this city. So in between, I'm not going to consider. So let me define this as a discrete one, that whether he is inside one city or another. It is known because he knows what is there. Everything is known to him. That map is fixed, so everything is known to him. It is deterministic. Deterministic means what? If he is into the state A, he moves towards the city B, so he would reach to this particular city. Sometimes it may be also possible that instead of B, he reaches to C. For n number of reasons. Huh? So people take the flight from Delhi to Mumbai, they landed in Chennai. For n number of reasons. I'm not going to that. So anything could happen, but here these things are deterministic. If I'm going to take the action, it is going to happen. Clear? What is the solution to this particular problem? Solution to this problem is that find the fixed sequence of actions that he can take and reach to the final thing. Okay. So, so we have to apply search, means how to find out the path. So there are a few more technical things. Sometimes we can tell this thing also. And what is the initial state in Arad? We can define like this. In Arad means whether he is in Arad or not. In Arad is the initial state. What are the actions possible right now? Various actions are possible. Right now, actions, 3 actions are possible. You can go to Cebu, Timisoara, or Zerin, 3 places you can go. Let's assume that these are the 3 adjacent cities. What is the transition model? Transition model is something that if I am in Arad, if I go Zerin, then I would be in Zerin. I would be in Zerin. The result of this particular thing that in Arad, if I go Zerin, then I would be in Zerin. What is the goal test? How can I see that what is the final thing? So you see that in Bucharest is the final state. Multiple states could be there sometime based on the examples, but in Bucharest is a goal test. You are there or not. What is the path cast? Path cast means how much you have traveled. What is the distance you have traveled? It determines the efficiency, how good the system is. So this problem solving agent is going to be a very simple one. Okay, so it is going to see that what is my state and see the based on the percepts and then formulate the goal. Formulate the goal. What I have to do right now? What is the goal? To reach to Bucharest. Okay, and then he formulate the problem. You have to formulate the problem. That problem formulation is required because it is a general agent I'm talking about, because it may be possible that, for example, if you have to go from here to here, if it is a highway. So right now you can go from here to here, but when you start moving, after 5 minutes you reach this particular place, you understood that there is something happened. This road is closed for 5 minutes. There is some VIP movement, or for 10 minutes, or for 1 hour. So you may take different paths. So every time you have to do the problem formulation. This is important. Then you search on this problem, because earlier initial state was this and final state was this. Initial state was this, final state was this. But when you reach to this particular place, now initial state is this, final state is this. It could be possible that you have to come back here completely and go back to this thing if the road is closed. What you can do? So now you have to apply some method to find out that what is my how can I find out the solution? This is the search thing. The search says take this action, then this action, then this action, then this action, then this action, and at the end you'll be able to reach to the goal. Search actually gives you the complete solution. But I am interested in this one, last one, because this is the action I have to take. So you take this action, first action, you find out that what is the first of this particular sequence, and then you take that particular action and you go back to again to this particular loop and take the again do the formulation. So you forget about this thing because because right now you can only take one action, and after that you again reformulate the problem, solve this particular problem, reformulate problem solving, reformulate problem solving. This is how the agent works. Does it make sense?
Yes, sir.
Yeah. So in the book also, if you see the book, I have taken this example from the book. They also deliberately don't show this map earlier so that you get confused something for some time. And when the map comes to you, it becomes more clear to you right now that this is the terrain, the problem we are right now talking about. So Arad is here. You have to reach to Bucharest, this place, and Zerin, Cebu, and Timisoara. These are the 3 places I have. So if the strategy is to follow the minimum path, so definitely the agent would move to here. He would spend 75. Then he have to no other choice. He have to go 71. Then he have to no other choice come to 151. He have to come out of this 99, 80, and 140. He's going to take 80. plus 80. Then out of 97, 146, he takes 97. Then out of 138, 101, he takes 101, and by this he reaches to localist. So he have to invest this much traveling time to reach to this particular place. You by yourself can see that this is not the optimal. Maybe the optimal could be this. Okay, it will be better way to come here. But based on my strategy, system is performing in this way. It's perfectly fine. Okay. Next thing that I wanted to discuss is, again, this was the one problem. We'll come back to this particular problem in more detail, multiple number of times to show you that when the different kind of strategies are there, how the system performance actually changes. Next thing, again, we are back on our classical problem, vacuum cleaner problem. So in this, if I want to do the problem formulation for the, what I'm going to do, I'm going to do the problem formulation for the toy vacuum cleaner problem. Again, there are two rooms, A and B. Okay, and the condition of room could be that all the rooms are clean, or there is a dirt here, there is a dirt here, there is dirt in both the room. These are the things only possible. And if I say that, so in all these scenarios, I could have my agent, means this vacuum cleaner is here in the first room, in the room A, or he is inside the room B, and inside the room B. So how many states we have? Total number of possible states we have. Can you tell me? How many states we have? Who is going to tell me? Eight number of states I have. Okay. So let me determine the state space. What do I mean by state space? That what happens in totality. Okay. So you see that let's assume that this is what the state is. One state. If you go to the left side, we also assume that it can go left, it can go right, it can suck. These are three operations. If we go take the left, he strikes with the wall and stay into the same room. Take right, he goes into this particular thing. Take right, same room. Take left, come here. These are the things. If he applies suck operation, then this room is cleaned. This room is cleaned. You take the left, he is inside the same room. Take right, he reads this thing. So I would not complete this. Can you complete this for me? For me, by yourself, you can draw this. This diagram is called what? State space. This diagram is called what? State space. Okay. In this state space, what is the initial state? What is the initial state? I'm not sure. Problem. If initially it may be possible that you are into this state, everything is clean, but some in one room there is some problem comes. Now your state changes to this. What you have to do? You have to take the left, and then you have to apply the suck. You'll be into this state. So what is the final state? These are the two final states. More than one states are there. These are the two states because I can name them now. I can say that S1, S2, S3, S4, S5, S6, S7, S8. These are the 8 states. Okay. I'm sorry that. Yes. Okay.
Yes,
So
sir.
these are the eight states. So I in the final state I put S7 and S8. All states, all other states we can just combine in this way. What is the initial state? I don't know. Anywhere I can start, and then what action I should take? I should take from right and suck. This is what the search is. Finding out that how you reach from here to here. Okay. So let me give you slide. So let me give you an example where I think instead of example, I give you the homework. Okay. So assume that you have a glass of 7 liter and a glass of 3 liter. 3 liter. Okay? And there is no marking on these glasses. And let's assume that you have a tub where a lot of water is there. So what you can do, you can fill it completely from this. This is filled, so you can fill it completely. Means what? Copy. Next. Next. So what you can do, you can fill it completely. For example, you have filled this one completely, or you can fill it this one completely. Okay. So, and then what you can do, one more thing that you can do, that you can drop all these things into this one. So what would happen? The 3 liter would be there and 4 liter would be vacant. This problem is called the water jug problem. What is this? Water jug problem. Water jug problem. So can you find out all the state space for me? Can you draw the state space diagram for me? So in the next class, everybody would be having this on your screen. I can just call anybody and ask you that show me your state space. So in this problem, what you have to solve is this: you have to get 1 liter in any vessel. 1 liter in any vessel. So how can you do that? Okay, how can we do that? Because there is no measurement. So again, this is you can say that one state could be that when you say that both of them are vacant, state number 1, state number 2, state number 3, and you can say that from 3 I go state number 4 and draw multiple things. So right now, if from very high level perspective try to understand, we have 2 vessels. In one vessel there could be 0 liter, 1 liter, 2 liter, 3 liter, 7 liter. In another liter there could be 0, 1, 2, 3. For all these cases, 0 liter is here, then 0, 1, 2, 3 liter could be here. How many cases? 8 cases. How many cases? 4 cases. So total number of state possible, 8 multiplied by 4 is 32. Okay. And some of them may not be reachable. That is a different thing. But not more than 32 states will be there. Everybody understand this? Yes or no?
Yes,
Can you
sir.
type yes? So this is what the problem I have. I have given you a problem that on your copy paste, use pen and paper to create the state space for this water jug problem. Water jug problem. All right. So last thing that I wanted to maybe tell this thing. There is another problem that we want to solve. So this, have you seen this? How many of you have seen this? So this is a kind of toy that a small boy is to be playing. So here is nothing is there. So what they do, they can slide this 2 over here. So it becomes something like this: 7, then blank space, then 4, then 5, then 2, then 6, then 8, then 3, then 1. Have you seen this? Yes or no? Has anybody seen this?
Yes, sir.
Then you can shift it here. It becomes what? Here is a blank, then 7, 4, 5, 2, 6, 8, 3, 1. Okay. So this is the game. So what is the final state? Goal state. This is the goal state that you want to be into this particular way. Okay, this is what the goal state is. So what is the initial state? Any jumble state can be initial state. Okay. So you start from any jumble state. For example, here, do something so that you reach over here. So how would you do that? Again, it's not very difficult, but sometimes you make some strategies, and by this you solve this particular problem. Okay. Okay, let me do the problem formulation for this. Yeah, what I'm going to do? The problem formulation. Let me do the problem formulation. What is problem formulation? Again, the same way I'm going to define that. What is the states? How they are connected? What is the initial state? I have to define all these things. No? defined. What are the states? So you may consider that this number as a 0 number. Okay. And let me come up with any sequence. For example, if I come up 0, 1, 2, 3, 4, 5, 6, 7, 8. So this, if I write this sequence, so you can map it. If I write any sequence, you can map this, that this is 8 is here, then 4 is here, then 1 is here, then this is blank, and here it is 2, here it is 5, here it is 3, here it is 7, here it is 6. So if I write any of this kind of string, it can correspond to what? A state? Yes or no?
Yeah.
So how many states are possible?
9 factorial.
9 factorial, because you can see that at the first place, how many values are possible? At the because there are it is a vector of the 9 size. So at the first place you can put 9 values, because 0 to 8 is 9 values. Then for the remaining 1 value have you already taken, so it is 8 values you can put over here, 9 value here, similarly 7 value over here, and last remaining one would be here. So all possible ways is factorial 9, which is written over here. Okay. What is the initial state? I don't know. Anything could be. What are the action possible? You know that action possible are left, right, up, and down. These are the 4 actions. Left, right, up, and down. What is the transition model? That you have to create, because for every states you see that from here I can go here, from here I can go here, something like that. Transition model. Everybody understand this? Try to make the transition model. Factorial 9 number of states. It would be impossible to make, but transition model exists. What is the goal test? Goal test is this, that you see that whether this particular value is what is the, let me say that the representation of this particular thing, if this is 0, 1, 2, 3, 4, 5, 6, 7, 8, if it is like this, I need to goal test. What is the path cast? Exactly how many steps you have taken. This way we can define this. Any questions on that? You know how to formulate this problem? Clear? One more problem, that is the 8 queuing problem, and Knuth conjecture problem formulation. They are actually left to us. You would come back to them in the next class. Okay.